for this section, you need a lot of algebra knowledge. Okay, so we're using all of these expansion laws. So let's have a look. This one, pretty simple, you just expand. This one using FOIL. This one is called difference of two squares. And these two are called perfect square. Perfect squares? Hold on, I forgot the name. Let me come back to it. We just did it in here. The perfect squares expansion. The perfect squares expansion. Okay? So you should know these by now because I'm teaching them to my year 10s. You should have learned it last year, basically. So basically, what you need to do is understand the patterns. I'm not going to explain the first two because it's pretty standard. The second one, basically the middle for FOIL, the O and the I cancels out, so that's why you're only left with A squared take B squared. This only happens if you want to find the pattern, all the A and the B are the same when the plus and the minuses is different. Now when it's a plus and it's squared over here, you get an A squared and a B squared. Similar with this one, if you get a squared, you get an A squared and a B squared. The only difference with these last two, is that if it's a plus, you get a plus. If it's a minus, you get a minus. The other two over here is a plus. So that's the only difference. You just got to write the pattern as it is. So hopefully you're able to utilize that really easily because you've done it multiple times in year 10, etc. So let's expand and simplify, and hopefully you're comfortable with doing some algebra as well. So with this one, you just expand. So first term, so you can write it. So you times them together. Oh, not times, plus. And then you do your second term. So you got your 2x. Oh, I'm not doing this right. What am I doing? I need to times them, meaning I add them. Silly. Okay, let's do that again. So when I times them, I add the powers. So let me do that again. So the next one, I get minus 3x, and then I go negative half, and then I do a negative half because plus and minus turns into a negative. So this turns into x. You can chuck this in the calculator if you would like, but if you can add fractions, you should hopefully know that it turns into 2 over 2, which is 1, but we'll do that next. 2x, and then this cancels out to 0, so x to the power of 0. And then this one turns into a half take a half, which is a minus 1. So we can simplify it a little bit further. So that's x to the power of 1. This is 2x, x to the power of 0 is just 1. So it's times 1. And then this one is 3x to the power of negative 1, which can be written as negative 3 over x. So if I simplify that a little bit further, it'll look something like this. X plus 2 take 3 over x. Alright, let's expand and simplify these ones. So you've got to use FOIL times these two, so it'll be 2x times 2x. And then you've got to times these two, so you get 2 to the power of x. And then you've got to do the inner, so you get 3 times 2x. Please don't accidentally write 6x. And then the last is going to be 3. This is very important that you don't accidentally write the wrong things. Now, 2x times 2x, the base is the same, so it becomes 2 to the power of x plus x. The second one is just 2x. This one is just 3 times 2x. It cannot be simplified. Please do not combine these as 6. And then that's just a 3. X plus a x is 2x. 2 to the power of x. Now what you hopefully notice is that there's 2x and then 2x, so you can add the powers together. So there's 1 lots of 2x and then 3 lots of 2x, so it's going to be 4 lots of 2 times x. Okay, and then we've got plus 3. So this can be simplified further, 2 to the power of 2 and x. So this can be written as 4 times 2x and then plus 3. B, let's have a go at this one. So this one, you can use one of the other rules. You can use the perfect square rule, and it was a plus, so you can use this rule over here. So I'm going to copy that down. So it should turn into a squared plus 2ab plus b squared. My a identifies as 7x. My b identifies as 7 to the power of minus x. So if I put that in there, it should be 7 to the power of x squared plus 2 times 7 to the power of x plus 7 to the power of minus x plus 7 to the minus x to the power of 2. So it's going to look something like this. 7 to the power of x squared is going to be 7 to the power of 2x. And then this is going to be 7 to the power of 2 lots of 7 to the power of x. And then if you times it, so it'll be 7x take x, which turns into 0, which turns into 1 ultimately. And then this will turn into 7 to the power of minus 2x. Alright, so this will further turn into 49x, and then this will turn into, probably should have a times sign, 2. This should turn into 1 over 7 to the power of 2x, because we don't like negatives. Alright, let's try factorizations. So with this one, you need to figure out what exists in both of them. So hopefully you can see that it's 2 to the power of n times 2 to the power of 3 in order to have that plus. So I've separated them. And then it's going to be 2 to the power of n. And hopefully you notice that these exist in both of them. So I'm going to factorize it out. And then the leftover is going to be this term. And then 1 for the next one. And that's how you factorize that question. B. Let's see if I can write it in a different way. 2 to the power of 3 and then plus. I'm going to leave that in a bracket because that's one term. And then 2 to the power of 3 for 8. So as you can see, 2 to the power of 3 exists in both of them. So it's all about manipulating what you see to make it look a little bit different, to make your life a little bit easier. So this is the leftover, 2 to the power of n, and then it's just plus 1 if I divide 2 to the power of 3 by 2 to the power of 3, and that's your answer. Alright, last one. So this one looks a bit tricky, but hopefully you can realize that it's going to be 2 to the power of n times 2 to the power of n times 2 to the power of n plus 2 to the power of n times 2 to the power of n. So hopefully you can see that these are common factors. So you can bring 2 to the power of n times 2 to the power of n out of the bracket. Okay, so you've got this left over to the power of n and then just plus 1 for the other one. Now your blue section can be simplified further. It can look something like 2 to the power of 2n because it's n plus n. And your green section looks something like this. So this one will need lots of practice. You might need to do lots and lots of practice. Please come talk to me if you're struggling with this one as well. Alright, let's factorize this one. So you're going to have to use those rules. So as you can see, I only see 2 terms. So I know for a fact this is going to be a difference of 2 squares. So what that means is I'm going to use this one. I'm going to look at a squared and b squared. So basically, this, I'll rewrite it over here, 4x take 9 is basically a squared take b squared. So it lines up like so. So what that means is 4 to the power of x has to be a squared, and then 9 has to be b squared. So I've got to figure out what a is, and I've got to figure out what b is. B is a little bit easier. 9 is b squared, so if I square root both sides, I should be able to find it easily. So b is 3. But a looks a little bit tricky. I can't really square root both sides, so what I need to do is make sure the 4 is the prime number. So 4 can be written as 2 to the power of 2, and then the x, so it's to the power of x, meaning it's 2 to the power of 2x. So I'm going to rewrite that over here as 2 to the power of 2x equals a to the power of 2. So if I cancel out, if I figure out what that means, so if I swap order a little bit, it's going to be 2 to the power of x squared is a squared. So as you can see, that this will be the a. So your a will be 2 to the power of x. So if I want to write my answer, it should be a plus b, a minus b as my answer. So my a was 2 to the power of x, my b was 3, and then 2 to the power of x take 3. So that's my final answer for a. Alright, let's do d. I might just move this out of the way so it's completely out of the way. That one was a hard one. Please let me know if you need me to explain it again in real life. So this one, I know that it's going to be all positive, so I know it's going to be this one, this rule over here, this one over here, because there's not 4 terms, it's just 3 terms, and it's all pluses. So now I know it's going to look something like that. So I know that if I have a look, so I know that this is a squared. It has to look something like this, and that's why. And I know that's b squared, and I know that's going to look like that. So I'm going to start with the a squared. Or maybe I'll start with the b squared because I find that easier. So if 4 is b squared, all I have to do is square root it, right? So therefore, b is 2. Found that really easily. Let's find a. So a is the harder one again. So I need to find prime numbers for 9. So I could rewrite 9 as 3 squared. And then I have x. So it's 3 to the power of 2x, which can also be written as another way, 3 to the power of x squared. So that equals a squared. So hopefully you can see that the a should be 3 to the power of x. Okay, so that one's a hard one, but it's honestly the same pattern over and over again. If you practice it more, you'll get it straight away. So I've already found a and b, but I'm just going to confirm it for you to make sure that if I find 2ab, I get this answer. So if I just use my 2ab, let's give it a go. 2 times a, which is 3 to the power of x, times b, which is 2. So it's going to give me 4 times 3 to the power of x, which is exactly what I have over here. So I know that my answer for a and b is correct. Now all I have to do is write my final answer. So it's going to be simplified as a plus b squared, because that's what it factorizes to. So it's going to look like 3x plus 2 squared, and that's it. So make sure you do all of those questions. Those might be the trickiest ones so far. Please make sure you get as much help as you need, and go to Homework Club if you need to as well. I mean Maths Club.